here's our April 15th worksheet. A review of our SOHCAHTOA. If you ever turn on a video and you don't hear sound within about 30 seconds, please email me, remind, Schoology, do something as soon as you can so we don't wait all day. I will try to make sure I catch this one, but if you ever don't hear it, please make sure you tell me right away. Alright, so to find all the 6 trig functions on this triangle, we have to find the other side. This is a triangle that's going to be very common, so hopefully we will memorize this one soon for that missing side. You put the two sides together that have the right angle. So we have x squared plus 16 equals 25. Subtract 16 from both sides. X squared equals 9, so x equals 3. Okay, so our theta is right here, which makes this the adjacent side. This one's the opposite side. And this across from the hypotenuse is always, or across from the right angle is always our hypotenuse. Okay, so sine is our opposite over hypotenuse. So this one is going to be 4 over 5. Kitty. Sorry, cat stepped on this screen. So the reciprocal would be 5 over 4. Our cosine is adjacent over hypotenuse. So that one's going to be 3 over 5. And if I flip that over, I get 5 over 3. And the tangent is opposite over adjacent. So that is 4 over 3. And the reciprocal is 3 over 4. Okay. This next one. Which of the following statements is true about this triangle? Choose all that apply. So if I was thinking of angle C or using this as my theta, then letter A says sine, so opposite hypotenuse, that would be true. If I did cotangent of B, cotangent is adjacent over opposite, and I need to be on B. So if I did adjacent over opposite, that would be 12 over 5. That one works. Secant of C. Secant is the reciprocal of cosine. So cosine reciprocal would be opposite over adjacent. So if I go back up here to C, that would be hypotenuse over adjacent. So that should be a 5. So that one does not work. If I do tangent of B, if I go back here to B, tangent would be opposite adjacent, so that would be 5 over 12. That one works. Cosecant of C, so we're back up on this one. Cosecant goes with sine, so it would be the reciprocal of sine theta. So sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite. So I would have this over this. So I would have 13 over 12. Excuse me. So that one is wrong. So A, B, and D are the only ones that are correct. And I should probably use better color. Okay. Let's pick a different color. Purple. Okay. If cosine theta equals 3 over 5, find cotangent. So I need a triangle. So I'm going to draw it this direction this time. I'm going to put my theta here. So if this is where my theta is, cosine is adjacent, and my hypotenuse would be up here. We just solved our 3, 4, 5 triangle up there, so we know this side would be 4 because of that work up there. All right, so I've drawn my triangle. So now cotangent would be tangent's reciprocal. SOHCAHTOA would make this opposite over adjacent. So my cotangent would have to be adjacent over opposite. So then that would give me a 3 over 4. given the triangle, find the cosecant. Cosecant goes with sine, it's its reciprocal. So if I had sine, I would have this piece. I don't have that extra piece though, so I'm going to have to solve for that. And cosecant means I'm actually going to have to flip it over. So it's going to be 25 over x. I just have to solve for x. So I have x squared plus 7 squared equals 25 squared. X squared plus 49 equals 625. So when we subtract that, 625 minus 49 gives me x squared equals 576. Take the square root and you get x equals 24. So this side's 24. So now our cosecant theta would be 25 over 24. Here's some more solving. So we want to remember our SOHCAHTOA. Look at what we're given and solve for the missing piece. So here I have opposite adjacent. So my opposite adjacent would mean this is a tangent of 50 degrees equals x over 12. To get x by itself, I'm going to multiply by 12 on both sides. So in my calculator, I want to do 12 tangent of 50 degrees. So x equals, we're solving for a side, so I need 2 decimal places. So I have 12 times the tangent of 50. So I have 14.30 in my calculator. Change colors. Here I have adjacent hypotenuse. So this one's a cosine of 57 degrees equals adjacent and then hypotenuse. So I have 3.2 over x. So remember, I would have to cross multiply these. And then x would be up over on this side, which means then to get this by itself, I would have cosine of 57 below. I always think of it as if I have to divide over here, then my answer will have to be division. So now I have 3.2 divided by the cosine of 57. This is not inverse. Inverse is when you're solving for an angle. This is just 3.2 divided by cosine of 57. And we get 5.875. So that would be 5.88 for that. Okay, now we need to find this angle. So now we're going to have to do an inverse of some sort. Okay, that's opposite adjacent. So that's a tangent. So we have tangent x equals 9 over 6. So x equals, in my calculator, inverse tangent of 9 over 6. And it said round to the nearest degree, so we don't really need a decimal on that. Inverse tangent of 9 divided by 6. I get 56.3. So since it's a 3, I can just call this 56 degrees. And my last one, I'm solving for another angle, so I'm going to have an inverse. This one's opposite hypotenuse. So I have sine x degrees equals 7.4 over 11. So I'm going to have to do inverse as well on this one. So x equals sine inverse of 7.4 over 11. So x equals sine inverse of 7.4 divided by 11. And we get 42.2, so this 42 degrees would be good. Okay, so that's today's lesson. There's more review. If you have questions, please email or remind me as soon as possible. Thank you.